Section 3.4. We're going to do the derivative of quotients. Suppose you have a function f divided by g, let's say, and you want to take the derivative of the quotient. How would you do that? Now, unfortunately, it doesn't simply equal to, well, I'll just take the derivative of each and do the quotient and call it that. But it doesn't work that way because the way the fraction works in the definition of the derivative. So you have to work it out a different way to see if there's any kind of rule that applies to quotients, taking derivative of quotients. To do that, we will go back to the original definition like this. Let's say if you have f prime of at a certain point A, okay? Now by definition, that is equal to the limit as t goes to A, ft over gt minus fa over ga, and divided by t minus a, and that is the original definition of the derivative of anything. It's the function minus the point as t minus divided by t minus a as t approach a. So how are we going to work this? Well, first thing we're going to do is do the common denominator trick. Put this thing, multiply this together and become a common denominator, and we'll put that denominator right down here so that we don't have two fraction lines. So we'll have t minus a, and we'll combine the two fractions into one by writing the two denominators, the two values in the denominator down here, and then of course these two will multiply together, becomes ftga, and minus this is gtfa. And so as you can see, this looks very similar to the situation we had in the product rule when you have two things stuck together and we can't split it apart very easily to do the limit. So we are going to do the same trick that we pulled in the proving the product rule or discovering the product rule. What we're going to do is add and subtract the same thing to it in order to make everything come out nicely. So the trick we're going to pull looks like this. We're going to have the first term, which is ftga. When we will subtract by this, faga, and then add faga to it. Because we're adding and subtracting the same thing, we haven't changed the equation one bit. And then lastly, there's minus gtgfa. And of course, the whole thing is going to be under more stuff now. There's t minus a, but there is also other things. There's gt, and then there's ga. So there's all this good stuff hanging out. And then we're going to pull almost identical trick. This looks identical to the product rule basically, except that there's extra stuff here. But the extra stuff won't pose a problem. So what we're going to do is put the extra stuff, t minus t approach a. We'll put this extra stuff up front as a fraction of gt times ga. Okay, we'll just take it up front, and then we'll split the fraction into two chunks, just like the proof in the product rule. What we have is ftga, faga, so the ga is the common factor here, which we will factor out. So we have ga, and then the rest becomes ft minus fa divided by, we'll take this part of the fraction, t minus a. And that, as you can see, is exactly f prime of a, so we're doing great. And then the next thing we're going to do is do a subtraction and take the gt here, because gt has a negative sign here, so we will have factor out fa, but we're going to factor out a negative fa, which means we're going to flip the signs around. So we factor out the negative fa, and what we left will be gt minus GA. See, then the minus and minus together will become the plus. So GT minus GA divided by T minus A. See, we have split this whole fraction into two fractions. And this thing is multiplying by everything. So everything is still equal. And then, so now we're pretty much done. Now we will take the limit. As we take the limit, as t approach a, this is just GA. So we have two GAs. So GA squared over here. And then over here we have GA, and then this is f prime at a, the definition of the derivative. So we will have GA times f prime of a, which is this thing, minus this thing is very similar, fa, this is g prime of a by definition as you take the limit, fa g prime of a. And that is actually called the product rule. So the product rule, as you can see, is slightly more complicated because you have a denominator here. To say it briefly, is called to take the derivative of u over divided by v. What we do is it'll be u prime v minus v prime u, and all over v squared. That's the shorthand for the quotient rule. And so let's do an example of the quotient rule now that we know how it is derived. So let's do a very simple, quick example of taking the derivative of tangent x. What is the derivative of tangent x? So let's say we want to know the derivative of tangent x. So far, we only know these things, okay? The polynomial right here, sine and cosine. What about tangent? Well, the tangent, of course, is equal to the derivative of sine x cosine x. And we know what these things are, sine and cosine right here. So we will follow this particular rule to crank out what the derivative of tangent x is. So to do that, we will follow the quotient rule, which says we'll take the derivative of u, the top, which is cosine x, times the bottom term, which is just cosine x again, minus the derivative of v, the bottom term, the derivative of cosine, which is minus sine x. Right here, derivative of cosine is, why don't I have that? It's minus sine. Anyway, the derivative of cosine is minus sine, and times the top term, which is u, is sine x. And everything divided by cosine and square the bottom. Okay, you square the bottom in the v, so square the bottom becomes cosine squared x, and which is equal to, well, this is cosine squared plus sine squared. Cosine squared plus sine squared is 1. Very nice. So we just have 1 cosine squared x, and that the inverse of cosine is called secant. If you don't remember that, try to remember that now. So this is simply secant x, and that's the answer of a quick, easy problem. And all kinds of variations of functions. Now you can take the derivative. So another one we need to add to the formula that you have to memorize is f prime of tangent is equals to secant squared. And you need to memorize all this stuff, and after a while you've done so much of it, it just becomes second nature.